Okay, so today we're going to revise using percentage multipliers to increase and decrease amounts. We're going to look at some reverse percentages and compound interest questions to revise those topics. You're going to need to be confident in increasing and decreasing percentages and also using multipliers, decimal multipliers to carry out percentage increase and decrease. If you're not confident in those, you can go to the Corbett Maths videos 238 and 239 and you can try out some of the worksheets and then come back to this. Okay, so the first thing we're going to look at is our percentage multipliers. Just quickly go over those again. Increase £50 by 60%. Okay, so that means we're taking the £50 amount, we're taking 100% of that £50 amount, and then we're adding on to it 60%. Okay, so 100% of that amount, add 60%, is going to make 160% of the original amount. Okay, and that 160% is going to be equal to 1.6. That's another thing you need to be confident with, is going from this percentage to this decimal. 160% is the same as 1.6. Okay, so if we do 1.6 times 50 in our calculators or using other methods, we're going to get £80. Okay, next one, increase £86 by 7%. We're taking 100% of this £86, we're keeping the full amount, and then we're adding 7% onto it. So that leaves us with 107% of 86, or 107% times 86, which is the same as 1.07 times 86, which gives us £92.02. Okay, just to revise that, I'm going to go through a few of these. Okay, just pause the video after each one, see if you can do it yourself. Okay, in fact, no, first we're going to look at decreasing amounts. So decrease £65 by 20%. Okay, so we're taking 100% of that £65, knocking 20% off. Okay, so it's 20% away from that full amount. Okay, so in other words, we're finding 80% of the full amount, which is 100%, take away that 20%, which we're decreasing it by. Okay, so 80%, that's the same as 0.8, which 0.8 times 65 is going to give us this. Okay, now we're taking this amount here, knocking 3% off. So we're taking 100% of this full amount and then knocking 3% off to decrease it by 3%. So 100% take away 3% is 97% times 320, which is the same as 0.97 times 320, which gives us that. Okay, now this is the point where we're going to review some multipliers. Okay, so how would you find 35% of a number? Well, you'll multiply it by 0.35. 35% is equal to 0.35. And now we're increasing the amount, so we're adding the 20% onto the original amount. Okay, so try this one. This one is one that students get wrong quite a lot because they think the multiplier is going to be 1.65. Actually, this is 100% of the original amount, adding on 6.5%. So you're getting 106.5%, which is 1.065. Okay, using multipliers to do reverse percentages. Okay, so all you need to understand for this is the idea of a reverse function, and I'm going to give you the most simple one I can possibly think of. 3 multiplied by 4 gives you 12. And if you go the other way, 12 divided by 4 gives you 3. So the bottom line is just a reverse function of the top line. And if you can understand that, and if you understand multipliers, you shouldn't find it too hard to do reverse percentages. My electricity bill has increased by 30%. My bill is now £104. How much was my bill before it increased? So I started with an amount, okay? That amount increased by 30%, so I times it by 1.3. And after I increased it by that amount, the amount became £104. So how am I going to get back to what that original value was? Well, all I'm going to do is I'm going to reverse the function. So I'm going to start with 104. I'm going to divide it by 1.3, which is the reverse of this, and I'm going to get back to that number that was there, which is £80. And if you try £80, try increasing it by 30%, you will get to £104, okay? Where students make the most mistakes, is they take this amount here and they simply knock 30% off this amount, okay? That is not the correct way to do it. Try reducing this amount by 30%. You will not get £80, okay? And we know £80 is the correct answer because if we increase it by 30%, we get to this. So don't just take this number and reduce it by 30%. Reducing this number by 30% is not the opposite of increasing £80 by 30%. This here is the opposite. This is how we reverse the function to get back to the value that would have been here. An item is reduced by 30%. The new price is £84. What multiplier would you use? How would you represent this using a number line? Okay, how are we going to find out what the original value was? So we started off with an original value. We decreased that amount by 30%. So we applied a multiplier of 0.7 to it. The new value was £84. So how are we going to reverse that to get back to what our original value was? We are going to do this. We're going to start with 84. We're going to do the reverse of multiplying it by 0.7, which is dividing by 0.7. And we're going to get £120. And try taking £120, reducing it by 30%. You will find that the answer is £84. Okay, again, the main mistake students would make here is they just take this number, increase it by 30%, and think that would be the correct way. Increasing this by 30% is not the reverse of the function. Okay, this is the reverse of the function. This is how we get back to the original value that would have been here. Okay, moving on to compound increases. Jenny has a sapling in her garden. Every month the sapling increases in size by 50%. Jenny says after 2 months the plant will have doubled in size. Is Jenny correct? Okay. This is what we would end up with, okay? And I'll show you how we get there, okay? So let's say this is Jenny's sapling. It's 12 centimeters at the moment, okay? After the first month, it increases by 50%. So it increases by 6 centimeters, which is 50% of what it was before, okay? But after this first month, it's now 18 centimeters. So if it's going to increase by 50% now, it's going to increase by 50% of its new amount. It's going to increase by 9 centimeters. So it's grown. So 50% of its total height is now more than 50% of what its total height was when it first started growing. Okay, so this time it increases by 9 centimeters. So the first month it increases by 6 centimeters. The second month it's grown. It's become bigger, so it now increases by 9 centimeters because it's a bigger amount that's increasing than it was before. Every month the plant increases by a multiplier of 1.5. So it starts off at 12 centimeters. After 1 month its length will be 12 times 1.5. After 2 months its length will be 12 times 1.5, which was 18, and then 18 times by 1.5. Okay, so we're taking 18, we're increasing it by 50%, and we get to 27. So what is the combined multiplier? it increased by 50%, and then it increased by 50% again. 1.5 times 1.5 is 2.25. So it's increased by a factor of 2.25, which is more than 200%. It's more than doubled. Okay, and if we take 12 and increase it by 2.25, you can try that on your calculators. You will get 27 centimeters. So this is the essence of compound change, is that as something grows, whatever percentage it increases by represents a bigger number than it did before. So things grow at a faster and faster rate. Okay, this time she has another sapling in her garden. Every month the sapling decreases in size by 25%. Jenny says after 4 months the plant will have disappeared. Is Jenny correct? Okay, what is the combined multiplier? Every month the plant decreases by a multiplier of 0.75, which is 25% decrease. So if it starts off at 12 centimeters, after 1 month its length will be 12 times 0.5, which is 9 centimeters. After 2 months, its length will be 12 times 0.75. So this is 9 centimeters here. This is what it is after 1 month. And then the second month, it decreases by 25% again. Okay, so it's now 6.75 centimeters. This should say, sorry, after 4 months, that's a mistake. After 4 months, its length will be 12 times 0.75 times 0.75 again and again and again. And its new length is 3.8 centimeters. So when we're doing compound decrease, we need to think, right, its full amount was 12. If its full amount was 12, we knock 25% off that, and then we knock 25% off the new amount to get this. Okay, so that's how we do compound decrease. We apply the multiplier again and again and again, however many times we need to. And the way we get the multiplier is by looking at how much the amount is decreasing by and taking that off 100%, taking that off from the full amount that the plant was before and coming up with our new multiplier. So this is the multiplier we're applying to the plant every month. I invest £360 and get 2% interest a year. How much will I earn in 5 years through simple interest? How much will I earn in 5 years through compound interest? Well, simple interest is simply this. It's 2% of the original amount was £7.20. Okay, so I'm adding that amount on every year for 5 years, and this is what I get. Okay, compound interest, so remember that's £396. Compound interest, okay, we need to multiply 360 by 1.02 to work out a 2% increase. So you're multiplying it by 1 to keep the same amount, and then adding on the 0.02 to add on the 2%. So your new multiplier is 1.02. This happens every year for 5 years. So we need to do this calculation 5 times. Okay, so we're increasing it by 2% to get our new amount. And then that new amount is being increased by 2%. And then that new amount is being increased by 2%, and so on for 5 years. Remember, it was 396 when we did simple interest. Now it's £397.47. So it increases at a faster rate because every year the amount of money grows, and 2% of that new amount is bigger than 2% of what the old amount was. Okay. I invest £490 and get 3.5% interest a year. How much will I earn in 5 years through compound interest? Okay, so I've got £490. I'm increasing it by 3.5% and then increasing it again and again and again and again. This is starting to get a bit long, so what we can do now is repeated multiplications of the same number. Hopefully you'll all see that that is in fact 1.035 to the power of 5. So we increase it by this multiplier to the power of 5 because we're multiplying it by this number again and again and again every year for 5 years. Okay, so that's the initial amount we start with. This is our multiplier, and then that's the number of times the amount is increased by the multiplier. So because this is interest per year, every year we're multiplying it by this. So this is the power we're using for that. And just bear in mind that that could be every month, it could be every minute, it could be every hour. So however many times the amount is being increased, that is the power we use. It's not necessarily increasing every year. It could be increasing at a different rate. Okay. Now, sometimes they try to trick you just to make sure you're not just mechanically applying the same formula again and again and again. Okay. I invest £2,500 in an account paying compound interest of 4% per year. After 2 years, I withdraw 30% of the total amount in the account. I then leave the account for another 2 years. How much do I have at the end of the 4th year? So how much do I have after 2 years? Okay, so I've got this amount. I'm increasing it by 4% and then increasing it by 4% again. In other words, by 1.04 squared. I get that. Okay. Now I'm taking this amount and I'm knocking 30% off of it. Okay, so I'm taking the amount, decreasing it by 30% to get this because I've taken 30% out of the account. Okay, so that's after 2 years. So I'm left with this, and then for another 2 years I increase it by 4% every year. Okay, so I take the amount after 2 years, and then this carries on growing at a rate of 4% a year for 2 years. And that's what I'm left with. I did round here, which maybe I shouldn't have done. Maybe that's going to be an inaccurate answer. Maybe I should have left that as 189280, but we'll move on. Okay, the amount in John's bank account increases by 20% and then 12%. By what percentage has his money increased? Hint, it is not 32%. Okay, so the amount increased by 20%. And then that amount increased by 12%. Okay, so these are the multipliers we use. And if we combine these new two multipliers together by doing 1.2 times 1.12, that's going to give us 1.344. And you can try that, say with £100. Take 100, increase it by 20%. You're going to get 120. And then take that 120 and then increase that by 1.12. So increase that by 12%, you're going to get £134.40. Okay, so it doesn't just increase by 32% because this amount here, the number's getting bigger, and then it's the bigger amount that's increasing by this. So you're actually increasing it by more than 32%. This here is called the combined multiplier. Okay, and we can go from here to knowing that that is an increase of 34.4%. Because it's 100% of the original amount plus 34.4%. Okay, and that's what the multiplier means. Radiation is caused by carbon atoms decaying at a rate of 3% per year. After 4 years, there are 6,000 atoms in a sample. How many were there to start with? So it's decreasing. The carbon atoms are decreasing by 3% per year. Okay, so this is what's called reverse compound interest. So it's decreasing by 3% per year, every year for 4 years. Okay, and then it's left with 6,000. There's 6,000 atoms left. So how are we going to reverse that function to find out how many atoms there were to start with? Maybe pause the video and see if you can work that out. Okay, this is how we're going to do it. We're going to reverse the function by dividing it by the same thing we multiplied it by in the first place, and we can work out that before all these atoms were reduced, the total amount of atoms was 6,777. Okay, I have £55,000 to invest for 3 years. I think that's a mistake. I think it should be 2 years. At the end of this 2-year period, I aim to have £5,408. What interest rate do I need to achieve my target? Okay, so I've started with 5,000. I'm timesing it by a multiplier squared because it's every year for 2 years. Okay, I want to increase it by a number for the first year and then increase that by the same number again for the second year, and I want to have £5,408. Maybe just have a go at that one, see if you can work it out. Okay, The way we do that is we want to find out what that multiplier is. We want to get that multiplier on its own. We want to find out what m equals. At the moment, various things are happening to m, the multiplier. So firstly, it's being multiplied by £5,000. Okay, so how do I get rid of that multiplication by £5,000? I divide both sides by 5,000. So that times by 5,000 is going to be cancelled out by that divide by 5,000. So I'm going to end up with the multiplier squared equals 1.0816. Okay. How do I get from that to this? Well, what's the opposite of squaring something? How do I get m on its own? I've got to square root it. So I've got to square root this as well. Try square rooting this on your calculator and you'll get to that amount. And so that's what the multiplier has to be. The multiplier has to be 1.04. So in other words, that multiplier of 1.04 is a percentage increase of 4%. So the interest rate must be 4%. So I've made m the subject there to find out what the multiplier is. And then I've gone from a multiplier of 1.04 to knowing that the interest rate must be 4%. Okay, so I hope you found that useful and good luck.